Okay, we're going to now do the second lesson of the data cycle with regression. This is going to be predicting X and Y. Okay, all right. So this is where this lesson has the most important contextual meaning. Is that what you want to do is you want to use these regression equations to help predict mostly future values, but you can also predict past values within the data set. Okay, so what you have to do, what is that predicting? What is X and what is Y? What do I mean? So you got to ask yourself in the question, and we talked about this already, is what is the independent variable, which is X, and the dependent variable, which is Y, and which things that those are underneath. All right. So when we did a question like this, the waiter makes a flat rate. We did this question already. How much will the paycheck be if the waiter works 120 hours? Okay. So what you want to do here, we've already done the regression, and I'll do that again in a second, is what is 120 hours? Which column is that underneath? That is underneath the X column. Okay, so what I want to do, okay, is I want to put X equals 120 into the third line and find where it intersects the graph. Okay, all right. So I'm going to go ahead and load this data in here. Okay, all right. So I got table. All right, 4, 7. 15, 25, 40, 60, 75, and this one will be 122, 176, 320, 500. Okay, just going to use my note packet to speed this along a little bit for us. Okay. 500, 770, 1130, 1400. Let me just double check that. 25, 50. All right, and we've learned from the previous one, this is a line, so Y, A, X, 1 plus B. And we learned that that's the value. Now, what we want to do is in this third line, because my problem asks for what is it at 120 hours? That's my X. So what I want to do is I want to zoom out and find where it crosses at. And where it crosses at, my solution is the other number. So the paycheck would be 2210. Okay, that's how simple this is. How much would it be if you worked 500 hours, where 500 is the X? So what I want to do is go, I don't need to delete it all. I just go X equals 500. Oops, too many. And I want to find where that intersects. That intersects right there at $9,050. Okay. How many hours would it take to make $30,000? Well, $30,000, that's in the paycheck, so that's going to be Y. Okay. So what I want to do in Desmos, instead of using X equals, I want to use Y equals and put Y equals 30,000. Okay, and I want to find where that intersects. I got to zoom out a bunch, put it right there. Okay, all right. I'd have to work about 1,663 hours, or 1,664 hours. Mr. Evans, which one is it? You can use either one. It's all a prediction. Okay, and that's how simple the prediction equation is. Once you figure out which one it is, that's how you do the problems. Okay, all right, so let's do another one. When will the height of the ball be at 7 feet? Okay, all right, so I'm going to go ahead and load the data. This is from the Nationals question. Okay, so 0.5, whoops, what am I doing? All right, table, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 20, okay, 30, 36, 38, 36, 30, and 20. Okay, now, I'm very far zoomed out because of the last problem. Always hit home and go back in there. Okay, we knew this one was a quadratic. We found that out already. But you would test it. You would start with line, and then you go to quadratic. Okay. And what you see is that r squared is that. Okay. So it says, when is the height of the ball 7 feet? Well, this is x. That's our time. That's the height of the ball, y. Okay. So 7 feet, that's the y calculation. So what I would want to do is y equals 7, okay, and find where it intersects, okay? Now, with the quadratic, there's some interesting properties where you could have two answers, okay? And basically you have to interpret sometimes whether they're logistically right or not. So basically, at 0.031 seconds, it's that, or if you click this other one, it's 3.986. 6.8. Okay, why is it important when the ball is at 7 feet? If you think about it, if you're going to go catch, okay, all right, it's going to take 3.9 seconds. For those of you who know baseball, the ball is at that's how long you have to maybe tag up, all right, and to get back to the base, okay? When will the height be at 0 feet, okay? Well, 0, all right, 0 feet would also be y, all right? So I got y equals 0. Okay, whoops, not 7 plus 0. Y equals 0. Okay, now, when you look at this, this is where you have to think. Can you have a negative time? And the answer is no. The only correct answer is 4.179 seconds. That's how long it takes to be at 0 feet. Well, what does that mean? For the ball to hit the ground. Okay, all right, we'll get into that when we get to quadratics. Okay. What is the height of the ball at 3.25 seconds? So this is x, okay? So what I would do there is I go x equals 3.25. And I want to zoom out until I find where it crosses. It crosses right there, okay? At 25.5 feet. Okay, all right? That's how you find those answers, all right? Your grandparents investing $1,500. Okay, so let's go to that one. Then I want to talk about years. I want to talk about, all right, 1, 3, 5, 7, 9, 11, 13, 1605, 1837, 0.50, 2103, 0.80, 2408.60, 2757, 0.60, 3157.20, 3614.70. Okay, and we learned that this was an exponential. Times b next to the first. Okay, all right. So you zoom out, you'll be able to see it. Okay. All right. And it says, when will it reach $5,000 in your account? Well, $5,000 is the y. So I go y equals 5,000. Okay. So that's going to be 17.79, or you can do 17 years, You could do 18 years, it doesn't matter, okay? When will it reach $10,000, okay? That's also a Y equals, okay? Because that money is in that column, that's the Y column. That's about 28.03 years, so about 28 years. Okay, how much money will be in your account by year 22? That's an X, because that would be 22 would be in there. So I go X equals 22. The home, oops, I want to zoom out till I get to 22. Sometimes it can be hard to see. There it is. All right, you gotta zoom in till you get the dot. $6,645 and 43 cents. Okay. Sometimes you just have to play around with the zoom in, zoom out feature. Okay. Now, let's see what I got in this next one. Now, the next thing I want to talk about, and you'll see these examples in a little bit. You'll see stuff like in the year 2000. Let's say the cost of let's say cost of McDonald's. Okay, let's say that is, let's say that's $4, and you're gonna be shocked, that's what it was. 2005, let's say it was $6. 2010, let's say it was $7. Let's say in 2015 it was $8.50. 2020 it went to $9, and then let's say in 2024 it's $11. Okay. Now we're not going to actually do this problem. That's not the point. But what you want to do when you get into the years is you want to set this year at 0, okay? And then what you want to do is think about, how do you go from here to here? That would be 5 years. How would you go from here to here? It'd be 10 years, here to here, 15, here to here, 20, and 24. And so these are what you want to put in there. Now, the reason for that is that sometimes, okay, all right, let's see what kind of correlation this is real quick. See if it's something worth doing. I just sort of made this problem up. I don't know if it's something worth doing or something not worth doing, so I'm going to see. Okay, 4, 6, 7, 8.5, 9, 11. Let's go 0.97 on that regression. 0.975. Count right. 9.7. Yes, this isn't a great one to do regression wise, but what you want to do is make sure that you've converted those, okay? And then you have to watch in your problem. Like let's say it says, what will it be in the year 2050? Okay, well, what is that really? Okay, you got to look at, well, that's really 50 for X. Okay, all right. Same thing is if, let's say it said, when will the price be $15? And let's say you get an answer of 38. Well, what does that mean? Well, that's going to be 2038. Because that's getting added from there. So that's just something to watch out for, okay? The next thing I want to talk about briefly to finish this lesson is the idea between correlations. Okay, so when you look at data, if most of your data appears like this or like this, okay, all right, this actually has some kind of correlation here, okay, all right, because you can draw a majority of the line. This is a negative correlation. This is a positive correlation. All right, now if you say this, Mr. Evans, what about this one? Well, this one has dots all over, so this is going to be no correlation. So that's just something you have to recognize. All right, what's some examples of that? Stuff that doesn't add up. Like, all right, when it's hot out, I eat tacos. Okay, the hotter it gets, the more tacos I eat. Well, that's not necessarily a correlation. Okay, all right, it has to be something that correlates. Like an example of this would be, you know, the more miles I drive, the less gas I have. Okay, all right, more miles, less gas. Okay, this one, more hours worked, bigger paycheck. Okay, and like this example, higher temperatures, more tacos. That doesn't really have something that's relative, it has no correlation. Okay, so that's just something you have to know about the data cycle. But now at this point, you're going to practice some more questions on your own.